All right, welcome back. We're now on phase 2, modification 2 of the Ada potato. We need to make the Ada potato smaller, and we need to make a second one. Now, making her smaller can be done in a number of ways. The easiest and most straightforward approach is open the Ada and potato images in your favorite photo editing software and change her size. So on Windows, for instance, I use paint.net. And when you do that, the image is now smaller. So that's a very straightforward way. You can also do it via code. If you go down to where you are drawing the Ada and the potato, you see that two of the parameters are the width and height that we are drawing at. If you manipulate those, you can make the images smaller. So here I'm dividing both the Ada drawing and the potato drawings by 2 in both dimensions, so that makes them even smaller. I could potentially even stretch them out if I wanted to, keep the potato's height to be half the size, but its width the same. And over here I made Ada's height normal, but made her half as wide. So now Ada will be skinny and the potato will be very wide. So you have some flexibility in terms of how you will manipulate these sizes. I don't necessarily mind one way or the other. For this particular case, I would just modify the images because there's no reason not to. The harder part is making the second Ada potato. Now, the Ada and the potato are, one single thing, being controlled by the timer and their mode and the X and the Y. If we want to have a second one, we're once again going to have to redefine our world. And in order to do so, we really want to try and have more fields. We need to represent not just the first Ada potato, but also the second Ada potato. There are many ways to go about doing this. One is just have two sets of all of our keys. First X and first Y, and second X and second Y. Since the two Adas and potatoes have different modes and timers, we'd also need first timer and first mode, and correspondingly second timer and second mode. So this is one way of structuring things, and that would be fine if we only had a couple things, but it still starts being a little sloppy and messy. So another idea, distinct from that, would be to start introducing a little bit of organization, a little bit of hierarchy to our world model. Now, in order to do that, we're going to need another record. So let's introduce a new Ada potato record. It will be a dictionary with the keys X, an integer, Y, an integer, mode, a string, and a timer, which will be an integer. And you see, I'm taking this and modeling it directly off of our existing fields. I'm extracting out, put that in the right place, I'm extracting out, just to get these all aligned, much nicer. Yeah. I've extracted out the mode and the timer. I'm leaving in the score because that will be consistent across all the Adas and potatoes. I also factored out the X and the Y. I can't just remove them entirely though. Instead, I'll put them back in as my first Ada potato and my second Ada potato. So now I don't have to have first X, first Y, first mode, first timer. I just have first and second, both of which are Ada potatoes. I've modified the model of my world, but I also need to modify the initial world. So a lot of this logic can be incorporated inside of my first and second dictionaries. The first one starts off with Ada, and I'm going to need two switch timers. I want them to go at different intervals. So we'll have first timer and first timer, and our second timer, which will move at a slightly slower pace. So this will be the first timer. And down here, I'll start her off a quarter of the way across the screen. For my second one, copy all that, paste it. Now I have my second eta over here. Start them off both as etas. I'll use second timer instead of my first timer. And I wanted to go 3/4 of the way across the screen. So 3 divided by 4 times window width. You see what I'm doing here, right? I've got 1 divided by 4 over here to represent a quarter of the way across the screen versus 3/4 of the way across the screen. So that puts them in the same vertical position, but kind of spaced out a little nicely. My world now is a bit more complex. I have some nesting. That's perfectly fine. I'm allowed to have dictionaries like this. I have to start being careful, remembering that this is a dictionary inside of a dictionary. They're both mutable. When I start modifying things, I have to keep track of the references. All right, so first third is modifying the world definition. Then we need to modify how we draw. We're going to need to separate out the logic for drawing an eta potato. A lot of different ways we can do this, but in general, having a new helper function is a good way to go. Draw eta potato will be a function that consumes an eta potato, which is we'll call that an AP. Its type is eta potato. We copy in our old game logic. The thing that we're consuming here is an AP, an eta potato. Eta potatoes have an X, a Y, a mode, and a timer. So we're allowed to use any of those fields. We no longer want the world's mode, we want the AP's mode. Same thing here, the AP mode, if it's eta, then we won't draw the world X, we no longer have a world X, we have AP's X and AP's Y. Same thing with the potato, we'll draw it at the appropriate location that we desire. Now, we need to be having the X and the Y position no longer always centered. Potatoes are no longer just centered. Instead, they have to behave more like the etas. They may not be moving, but they still have a separate X and Y coordinate on the screen. We change back the potato. And at this point, our draw image centered function is no longer helping us. So it's probably time to delete it. Happens all the time, right? We no longer need the code, we get rid of it. We want to write a nice bit of documentation here explaining that this function draws a eta or potato at its position on the screen, depending on its mode. Down in draw world, we no longer have anything drawing etas and potatoes. So we're going to need to use our draw eta potato function, and it consumes a eta potato. All we have right now is a world, but as we remember, worlds have an eta potato, 2 of them. We want both to be on screen, so we'll call both world first, and we'll have a separate call to eta potato for world second. You see how we could easily extend this to have a third and fourth if we so wanted. The score is still part of the world, so that part stays the same. Looking down at our update world, and recognize here, I haven't gotten to run very much recently. That's making this very difficult. Right now, I could have errors in my drawing or my initial world, and I still don't know. But until I update the logic across here, I can't really run it. Whenever you make a change, no matter how small, you're in this sort of state of semi-broken code. This is why you always want to make very small improvements at a time and make regular backups. Because if this goes wrong, I'm going to have to restore from where I left off, from where I started. Hopefully things will keep going smoothly though. Down here in my update world, I have a bunch of code that's meant to handle updating my eta potatoes. Now all of that is no longer appropriate for worlds, so once again I need to extract out this logic into a new helper function. And if you think about what I did for my draw eta potato, I'm going to do the same thing for update eta potato. So once again, I'll have a world that takes in first, and I'll have a function eta potato, update eta potato, that consumes the world's first and the world's second, both of which are eta potatoes. the actual solution, the actual code for update Ada potato consumes an Ada potato, doesn't produce anything, and now everywhere I previously was referring to world, it's actually going to be the Ada potato that we're currently working with. So this is, once again, only modifying the X, the timer, and any other corresponding things. We don't pass in world for switch mode because worlds no longer have modes. Instead, we pass in an Ada potato that we wish to modify. So we've got to go update switch mode to consume Ada potatoes and update our explanation. AP is an Ada potato, the Ada potato to modify. Swap the AP's image between either Ada or potato. We no longer have worlds because we nested all that logic inside an Ada potato. But we didn't change most of the rest of the data model, so by and large, we were able to retain a lot of our existing code. We just kind of moved it inside of something else. We'd want to update the documentation here to indicate that this is a function that updates the state of the Ada potatoes timer and image and position, just to be more accurate. Args is a function that consumes a Ada potato. Sorry, args, so it's a function that consumes an Ada potato. The Ada potato to update. Back up here, we probably want to update our worlds documentation to clarify the world's first and second Ada potatoes. Or perhaps more succinctly, update all of the world's Ada potatoes. The only other function that we've implemented is handle mouse. We don't technically need that yet in order to run our game. At this point, we should be able to run our game, and if things are working just fine, which they aren't, then we should have been able to play. So let's go check out the error message, and it's referring to switch timer, which you may recall I'd gotten rid of. So switch timer is now going to be more complicated. We have first timer and second timer, depending on which one we're dealing with. Now, that's going to be pretty hard to handle. We'll deal with that in the next video. For now, we'll keep our two Ada potatoes on the same clock and just use first timer. So that should allow them to switch between the two versions. It does look like the Ada potato is getting repositioned when it switches over to the potato. So we'd probably want to try and think about how we want to handle that. That's caused by this line of code right here. Potentially we want to just get rid of it so that she's no longer resetting herself. If we wanted to prevent potatoes from moving, we'd bring back our if statement saying, oh, if this Ada potato's mode is equal to Ada, then increment the X position. And that prevents potatoes from moving, but allows the Adas to continue. Okay. Finally, we have our handle mouse aspect. This is still consuming a world, but it needs to be working for both Ada potatoes. In theory, we don't need to do very much. We don't need to necessarily process this for both Ada potatoes, but the current logic doesn't work. We can't just say world mode because worlds don't have a mode. We might say that we only care about the first Ada's mode. So we could just access the mode inside of the first and only rely on the mode of the first Ada. So that's an option, and if they're both moving on the same timer, there's no difference. We'll need to refine that logic once we get further down into the next modification. But for now, we have our two Ada potatoes.